All right, so just a quick recap. We're simplifying. We are We are resisting the urge to Abdul. Hello. So we are not going to be dividing these two until we simplify. So we've got the 4 plus or minus. Who can remind me, how do we simplify a surd? Hang on, that thing.
When you find the square that you can times it by.
Right, a square number that goes into 20. So what is our square number that goes into 20?
4.
4, that is correct. All right, so I'd like to think that we don't have to do this working out to the side. We can straight away realise that that is 2 root 5. If you need to do the working, do it. You just have an extra line. Okay? And now I can divide each of these, right? Because that's a whole number there. I can divide each one by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. And we just write root 5, not 1 root 5. Sweet? Right, we look at this one. Why am I getting you to do these? And by the way, I should have said try and do it without a calculator, not even a scientific. Okay? What is the biggest number that goes into this one? Yes. Yep. Well done. Like, well, I would have thought, first of all, most of you would have gone 4, and then you go 4 times 20 is 80, but we already know that 80 has a square number that goes into it. And 4 times 4. So if you think, I don't know my 16 times tables, a little bit of writing instead of keeping everything in your head, write it down, and it's quite nice then. So we end up with that's root 16 times root 5 all over 6, which becomes minus 10 plus or minus 4 root 5. Can I cancel that any further? Niomes. How do I cancel? Right, we can see 10, the 4, the 6, they're all even. So we can divide each of those by 2. So minus 5 plus or minus 2 root 5 over 3. You can leave it like that. If you look at answers in the back of a textbook or something that says 5 over 3 plus or minus 2 root 5 over 3, sure, same thing, but I don't think you have to keep them separate. Are we good with that? Remind me. Big thing. We had the quadratic formula, absolutely, and there was a special part of the quadratic, right, the discriminant. So our quadratic formula, which we are by now dreaming about. Have you all seen the song for the quadratic formula? Oh, right, I'll play it for you today.
Is it Adele?
Yeah?
Oh, is it the school kids?
Yeah, Adele, but there's also One Direction. So there's our quad formula. Shh. This bit here was called the discriminant. Discriminant. We had a maths club at Glenunga, and we made T-shirts. We do not discriminate. And it had the. Anyway, what did we learn? What did the discriminant tell us about our graphs, about our quadratics, our parabolas? What did they tell us? You're playing a lot. That's well done. Who can mix it up? Back row. Someone from the back row. What does the discriminant tell us? What does the discriminant tell us about our graph? What about the roots? All right. So when the discriminant is greater than 0, that means what? 2 real roots. Right, it can also graphically mean 2 x-intercepts, distinct, right? 2 cuts the x-axis twice. And of course, when it equals 0, what does that mean? 1 repeated root. Draw me a picture. What would the picture look like? Worth 1,000 words? Thanks, Lil. Right, it's just touching. Okay? I'm going nice and happy. I'm happy today. So this is what we would call convex. Right, and we know that it's convex. How do we know just from looking at an equation that a graph is convex? Yeah, but how do I know from looking at the equation? Right, the a value. So y equals 3x squared, take 5x plus 2. Straight away, this is positive, so I know that it is convex, as opposed to y equals minus x squared plus 3 seems to be on my mind today, right? That means it's concave because your a value is there. So all of these things lead us to have an idea of what our quadratic looks like. Agreed? Okay, we are moving into sketching our quads. And so we've got some really important aspects of our quad that we use to sketch. And we're going to sort of do everything in one today, and then you can just go through and do your thing. Stop talking right next to me, please. Okay. Important things that you would have to find and possibly label. You okay, Sashwat? You all right? What are the important things that we have to label on our quadratic parabola, our quadratic graph? Give me one. Oh, she's starting with axis of symmetry. All right. Axes? She likes it. Now, your axis of symmetry is right smack bang in the middle. How do we find it? Algebraically, how could we find it? Pipes? Adds. Right, so we've got a formula for it. We've got a formula for the axis of symmetry. Minus b over 2a. It is written nicely in your textbook in a minute where you'll be able to go through. It's going to take you through step by step, and I can as well. But it should be something that rings a bit of a memory from year 10. If it doesn't, it's not that difficult. What are we talking about with the b and the a? The coefficients. We've just done that with the quad formula, yeah? So it's nothing overly new. How else could we find our axis of symmetry?
The average of the two.
Yeah, it's the average of your x-intercepts. Right? Add them together, divide by 2, bingo, bango, bob. So if you don't have to do the whole shebang-a-bang, don't do it. You can actually just observe. Now, there's one other way. Oh, yes? Right, so when we complete the square and we have it in the form x take h squared plus k, right, x equals h is going to be your axis of symmetry. Okay, so we've got axis of symmetry covered. What else is important on our graph? I think we need it. And hello, I will cut and paste this, put it on OneNote for you. So don't be madly scrambling. I'd rather you listen and we have a look. What else do we need for our quadratic graph? Playing again. Come on, who's going to play? Who's going to play? Dim, Bigfoot. Yeah, give us what else do we need to sketch it?
Y-intercepts.
Excellent. So our y-intercept, how do we find our y-intercept? You make x equal 0. Okay, so as an example, e.g., if I've got y equals x squared plus 3x take 5, when x is 0, 0 squared, 3 times 0 is 0, my y-intercept will be 0 minus 5. Do we agree? That's simple. Okay, another thing that we have to know about our graph. We've got axis of symmetry. We've got our y-intercept. What else do we need? Yeah, if you got your y-intercept, you got to have your x-intercept. because that's when y equals 0. So again, as an example, what we might be solving is x squared plus 5x take 6 equals 0. How do I solve that? Give me one method, Tara. How do I solve a quadratic? You could go quad formula, absolutely. What else could we do? Or try. I should say, what could we try? Yep. You could try to factorize. I'm saying try because not all the time can you factorize every expression. What else could we do? Complete the square. So we're talking algebraic things here. Obviously, you could use your graphics calculator as well. What else is important for our graph? One more really vital thing. Aiden? There's a key feature on there that we need. We've got our y-intercept, we've got our x-intercept, I've got our axis of symmetry. There's something else. Pardon? No, that's with our trig, principal axis with our trig. Another thing, go loose. It is in fact, yep, the vertex. You were thinking it, yep. And how can we find our vertex? Got two options. Cokes? Come on. All right. So everything here that we did to find the axis of symmetry, right? This is basically giving me the x value. It's giving me the x value of my vertex, isn't it? So if I have my x value, how do I find my y value? Sub it back in. So we're going to do all of this in a minute. But as Addison was saying, if we've got x minus h, if it's in the completing the square form, our vertex is in fact hk. I love people are randomly copying. I'm going to write this, copy it and put it on. It's okay. You want to, that's fine. And last but not least, we already talked about it. What colour have I got left that I haven't used? Pink. I have, oh my God, how did I not? Oh, pink was the graph. Anyway, we knew when a is greater than 0, so we just talked about that one already. And when a is less than 0, it's concave. So all of these things, when we're looking at our equation, we should know. And you might laugh out there or roll your eyes and go, oh my God, we know this. I have had students, and we've all had it. We're in the office and we show the tests where we have something like this, and it's clearly, has to be, it's a positive, it's convex. God knows what the student has typed in their calculator and they draw us a concave. Watch the video, yeah, Heath? So, look, see if your answer is reasonable. Well, let's get started. Using the axes x-intercepts only, sketch this graph. Piper, thanks. So first we look at this and we straight away go, is it concave or convex? Convex, we know that straight away. What's our y-intercept? Just from looking at that equation, what's our y-intercept? So how do we find our y-intercept? You may. X equal to 0, so 0, 0. So what's 2 times 3 times minus 1? Right? We can see our x-intercepts are minus 3 and 1. If I asked you to draw on this graph so I now say, looking at all of that, now can you draw y equals x plus 3? X take 1. What would that look like in comparison to this? It would be a bit wider. Absolutely, it would be wider dilation, right? Because, so we would go like this, it still has the same x-intercepts, but your y-intercepts would change. what if I asked you to draw, well, you do one that you think would prove a point. I was thinking that too, negative. So what about negative 6? What would that look like? Hang on. Now, Wendy, we've got a surprise. Wendy's just walked into the room. Would you like to say something to the people at home, Wendy?
How are you all? Heather, Garner.
Right, so what would that one look like? Definitely concave. Yep, and the 6, the bigger number, makes it thinner. Where did we see stuff like that before? Your trig graphs, right? The amplitude affects it the same way. Same way. Same way. What do you want to say?
Same way.
All right, so let's get started. I know some of you have already started this, but we are now working our way through 2D1, 2D2, and I have a homework task for you as well. Love you, go. So we look, before we even do anything, we know that this is going to be convex. Why? Positive x, yeah? And positive in front. But what do we need? We want to use our axes intercepts only. So just looking at this to get your x-intercept, we're making y equals 0. Is anyone doing this with me? All right. So what we're solving, so this one is nice. It's already factorized for us. Happy days? Right. What take 4 equals 0? 4 take 4. So then 0 times anything gives me 0. So it was nicely already factorized for us. If it was me writing your test, which I am, I would be mean and I would not give it to you in a factorized form. I would make you factorize it yourself. Yeah, in your face. All right, so that's our x-intercept. Can we also get our other axis, which is our y-intercept? And we've already been through that. That's x equals 0. So when x is 0, we're saying, we're going to say y equals, what's 0 take 4? Minus 4. What's 0 plus 2? 2. So we get minus 8. Okay? So now we want to sketch our graph. So have a look at your axes first. We're having to go through 4 and then minus 2 and down to minus 8. So I'm probably going to, oh, that's crooked. And down to minus 8. Okay? Here's a big tip, aides. Draw your x-intercepts first, right? And they don't have to be to scale. Philippe, this is a sketch. So here we put minus 2. Here I put 4. I know that it is convex. Hair's looking lovely. Know that it's convex and we go try and make it symmetrical. And now I put my minus 8 in. Right? If you try and put all your intercepts in first and try and connect, it's very difficult. So go through, done. Get full marks by making sure we've got y, we've got x. Yeah, practice nice and smooth. It's not an easy thing. Mine's a bit wonky, but anyway, not too bad. Okay, we're doing B. Before we do anything, concave or convex, peeps? It's concave because we've got that. Do be careful. It could be this. 3 take x. 3 plus x. Would this be concave or convex? What would this one be? Negative x times x gives you minus x squared, right? But then you're timesing it by a minus. So what's a minus times a minus? Positive. So this one would be convex. So don't just get into the habit of looking at that and going, oh, boom, done. Make sure you're looking at, if you expand and get x squared, is your x squared positive or negative? All right, so we've got our x-intercepts. Y equals 0. Once again, it's already nicely factorized for us. So what would be my x-intercepts? Hit me, Bales. Yeah. 4. Sorry for those watching the video, but you just heard me go, ee. Okay, so we've got 4 and 0 and minus 2, 0. And now what about my y-intercept? X is 0. So we're looking over here and we get minus. Why did I go minus times? 0 take 4 is negative 4. 0 plus 2, 2. Negative and a negative makes a positive, so we get 8. You get your ruler out. Oops. Wait. Oh no, did I just pause then? Oops. I hope you got that. Plan of attack, what would you do to go through to make it quick? Yep. Find the x and y intercepts. I would, even before that, sorry? Convex, concave, rule out. So with this one, clearly convex, I'm not even going to entertain this as an option, right? So pretty nice. Use the vertex, axis of symmetry. Hello. Paying attention. That's beautiful. So when it's in this form, remember we talked about this? Who can tell me what the vertex is just by looking? Go.
Negative.
No.
1 over.
It's 1, 3. Right? What's the vertex for this one? Sorry, you can't see it at home, but this one. Minus 2, 1. What's the vertex for this one? 1 minus 3, and it will be concave, right? But whether or not this value here, does that affect your vertex? No, it just makes it squishy, wider, turns it up, turns it down, but the vertex, the turning point, stays the same. Okay, so again, matchy, matchy, matchy. You are then going to go onward, and I am reasonably confident that you know how to do the completing the square, because we've done it already for solving. The only thing that you have to do now is, instead of putting on one side, we have everything on the one side, right? So don't separate, put it all on one side, and then you can read off your vertex. All right? Psst. For some of you who might have had trouble with completing the square, if you check your OneNote, I put some stuff there from last year when we did completing the square with an odd and an even, so have a look. And you've got a worksheet to do. But if I could ask you by Tuesday to have finished that exercise and this one, which is, oh, my scroll, come on, scroll. Exercise, tell me, Gracie, 2D2, so 2D1 and 2D2. Okay? And the worksheet that I'm about to give you. Thank you, goodbye.